Imagine trying to figure out the exact architecture of a house while you are permanently locked inside a single, windowless closet. You can map the drywall. You can measure the vibrations in the floorboards. You can track the temperature shifts under the door. But you can never step outside to see the roof, the yard, or the whole structure from the driveway. That is our exact predicament with the cosmos. We are trapped inside the fishbowl. Every single piece of data we have ever collected, every photon of light, every gravitational wave, every tick of an atomic clock comes from a perspective deeply embedded within the system we are trying to measure. We are on the inside, looking in. And right now, that confinement is breaking our favorite toys. For years, astrophysicists have been tearing their hair out over a massive, uncooperative discrepancy in how fast the universe is expanding. Two completely different, statistically bulletproof measurements. Two completely different answers. Look backward in time at the ancient afterglow of the Big Bang, the cosmic microwave background, and the universe is expanding at a relatively sluggish 67.4 kilometers per second per megaparsec. Look around our own cosmic backyard at local Cepheid variable stars and exploding supernovae, and the universe is speeding along at a brisk 73 kilometers per second per megaparsec. Same universe. Same question. Completely different answer. For a long time, the scientific community has treated this like a plumbing leak, a frustrating error waiting to be patched. One side must have a hidden flaw. Or some undiscovered particle is waiting in the wings to make the math line up. But what if the math isn't broken at all? But here is the deeper question. What if the universe doesn't even want to give us a single answer, because a single answer doesn't actually exist? To even talk about an expansion rate, we rely on a comforting fiction, the idea of a constant. In physics, a constant feels safe. It is a universal factory setting, like the speed of light or the charge of an electron, that stays the same everywhere in the universe. We slap that word onto the Hubble parameter, assuming the universe has a master dashboard, ticking away at one uniform, centralized pace. Except Einstein's general relativity tells us that a master dashboard is a physical impossibility. There is no universal now. There is no master clock. Space-time is local, dynamic, and relational. Gravity warps time, motion alters clocks, and space itself stretches at different rates depending on your neighborhood, your mass distribution, and the epoch of time you happen to inhabit. So why exactly do we expect the universe to hand us a single, monolithic number for its expansion rate? If space is fundamentally stretchy, relational, and caught in a perpetual state of motion, then a global average might just be an illusion born of our desperate need for neatness. To the ancient light of the early universe, the expansion rate is 67. To the chaotic, heavy web of local galaxies we inhabit, the expansion rate is 73. Both measurements are completely, logically true within their own frames of reference. The universe doesn't need to resolve into a tidy average. It can hold two valid, conflicting realities in motion at the exact same time. In quantum mechanics, we are comfortable with the idea that particles exist in a superposition of multiple states until an observer forces a measurement that collapses the system into a single reality. Scale that up to the galactic level, and we hit a fascinating inversion. On the cosmic scale, our inability to observe from the outside means the universe doesn't have to collapse at all. It can just keep doing its own thing. If the Hubble tension isn't an error, and it isn't a glitch waiting for a patch, it might be something far more humbling. It might be the universe reminding us that we are just fish trying to measure the humidity of the ocean. So what happens when the math stubbornly refuses to reconcile? Do we keep hunting for a ghost number that was never meant to be found, or do we finally accept that the universe is far too wonderfully weird to be pinned down by a single digit? We sent this thought experiment to some of the greatest minds in history and science, starting with the man whose equations started this whole conversation. Here is what Albert Einstein had to say. Einstein opens with a compliment. He agrees entirely that a global master dashboard is a physical impossibility. General relativity tells us that space and time are local and relational. There is no absolute now and no universal clock ticking away in the void. So far, so good. But then Einstein draws a firm line. He says we are making a dangerous leap from relativity to relativism. Yes, space is dynamic and local. But that does not mean the universe gets to hold two permanently irreconcilable truths. Physics is not a democracy. If the math fails to reconcile, it means our description is simply incomplete, not that the universe is playing coy. In short, Einstein gives us half credit. The relativity argument is valid. The leap to permanent irreconcilability is, in his words, a bridge too far. Nature is not playing coy. The script is just incomplete. Next up, Neil deGrasse Tyson, who loves the poetry but wants us to check our math before we break down the fabric of reality. Tyson's argument is grounded in scientific history. When two rigorous methods give two different numbers, the answer is almost never that the universe is playing hide-and-seek with its constants. The answer is usually that someone made a mistake, someone has a hidden instrument bias, or we are missing a new piece of the puzzle. His candidates for the real culprit include hidden instrument biases in our distance ladder, calibration errors we haven't spotted yet, or a brand new cosmological term, something like early dark energy, that shifts the numbers without requiring us to rewrite the fundamental nature of reality. And then there is Michio Kaku, who looked at our thought experiment and said, "Wait a minute. This actually dances right up to the edge of some very serious, cutting-edge theoretical physics." In M-theory and string theory, our universe might actually be riding on a higher dimensional membrane, a brain, floating in a vast higher dimensional bulk. If our local neighborhood is experiencing gravity or dark energy leaking from a parallel dimension differently than the early universe did, the expansion rate would look different depending on where you are sitting. Kaku's verdict is the most generous. He says we are not entirely wrong. In M-theory, reality is multidimensional. What looks like a tension in 4 dimensions might just be our instruments catching ripples of a much larger multiverse. The Hubble tension might not be a measurement error at all, it might be the universe's higher dimensional architecture leaking through. 3 brilliant minds. 3 different reactions. Einstein says our description is incomplete. Tyson says check the data. Kaku says the tension might be a window into higher dimensions. None of them say the tension is boring. And none of them say it is solved. Here is what this thought experiment actually reveals. The Hubble tension is not just a number disagreement. It is a stress test on our entire framework for understanding the universe. It is the universe holding up a mirror and asking, "Are your tools good enough to see me clearly?" And the honest answer, right now, is, not yet. We are still in the fishbowl. Every photon, every measurement, every equation we write, it all comes from inside. But that confinement is not a defeat. It is the frontier. The tension is not the end of the story. It might just be the most exciting chapter. Thanks for thinking about the universe with me today. If this made your head hurt in a good way, that is exactly how it is supposed to feel.